Hi everyone, this is the second page of the Chapter 5 exam review for Algebra 1B. We're picking up with a few more systems to solve here. So looking at number 7, this is another one that kind of jumps out at me as a substitution problem because I see that y is by itself over here. So it would be really easy to take what y is equal to and plug it in place of y down here. Now notice that this equation is not solved for y. It doesn't need to be. I still have some students who always want to get y by itself in both. You really don't have to do that. You really just have to do it in one. So I'm going to rewrite this bottom equation, putting this 3x minus 5 in place of y. And here's what that's going to look like. It's going to say 6x minus 2 times 3x minus 5, because we're using that in place of y, equals 10. Now I can distribute. Just make sure that when you distribute that, you treat that like a negative 2. So this is going to be 6x, negative 2 times 3x is negative 6x, and negative 2 times 5 is positive 10, equals 10. Now something sort of unique happens here. You'll notice when we go to combine our like terms, our x's actually cancel out. Okay, that doesn't happen a lot, but it did here. And so what we're left with is just 10 equals 10. Now we had a problem that was similar to this on the previous page. If you watched the previous video, this will look familiar. Problem number 4, if you look at here, we ended up with 0 equals 0. This is the same type of situation. I ended up with two of the exact same number on either side. Came about in a slightly different way because this time I was using substitution, but it still means the same thing. Anytime you get something like this, your answer is infinitely many solutions because they're in fact the same line. Okay, if I graphed them both on a coordinate plane, they'd be lying right on top of one another. Okay, number 8 looks like an elimination problem is going to work well for us. The y's look pretty tough to get rid of, but the x's play pretty nicely together. Because I could just turn this into a negative 4 and I'd be good to go. So to do that, I'm going to multiply on the top by negative 2 so that I can turn that into a negative 4. That's going to give me negative 4x minus 10y equals negative 18. Now I'm going to kind of ignore that top equation and add these two equations together. So this is gone. 16 minus 10 is 6, so this is 6y equals negative 6. Divide and divide, and I end up with y equals negative 1. And now I'm going to take that negative 1 and plug it back into whatever equation I feel like. I'm going to maybe use this one right here, this second one. So I'm going to say 4x plus 16 times negative 1 equals 12. Well, 16 times negative 1 is just negative 16, so that's 4x minus 16 equals 12. Add 16 and add 16. I end up with 4x equals 28. And then if I divide, I get x equals 7. And so as a coordinate, I would say 7 comma negative 1. Okay. And then number 9. Number 9 is another one where elimination looks like it would work out pretty well. Yeah, I guess I'd probably do elimination here. So again, looking at my x's, and you could do x's or y's here, but if I could get there to be a 3 in front of that x, a 3x and a negative 3x would cancel out. So I'm going to multiply that top equation by 3. Distribute. So I get 3x minus 9y equals 24. Now my x's cancel out because that's what I wanted to happen. Remember, I was trying to get this to be a 3x, but this is another one where just accidentally the 9y and the negative 9y are going to cancel as well. So this whole side of the equation is equal to 0. However, what's different between this one and number 4 that we did on the previous page is this time these ones do not cancel. 15 plus 24 gives me 39. And we know that 0 does not equal 39. So this is different than this. okay, because I ended up with two different numbers instead of two of the same. For something like this, this tells you that there's no solution. There's no possible number that makes that true. Okay, these would be two lines that are parallel to one another. Okay, so let's look at number 10. And this sort of speaks to like number 7 or number 4 on the previous page. We want to make this have infinitely many solutions. Well, let's think about what happened when we had infinitely many. And in fact, I might refer back to number 4 again. Number 4 back here, this is on page 1, came out to be infinitely many because we multiplied by something to get the x's to cancel, but at the same time that we did that, it just so happened that the y's canceled out as well. Okay, so you work to get one of them to cancel, and just coincidentally, the other variable cancels at the same time. So that's kind of what I want to shoot for here. Is I don't know what n is, so I can't make these cancel, but I can work to get the x's to cancel. So I'm going to multiply the top equation by -3, okay, because I want the x's to cancel. And that's going to give me a -6x plus a 9y equals a +30. And so you'll see that the x's are going to cancel, that this is going to cancel, and what I'm looking for is what could go right there that would make this cancel as well, because infinitely many happens when everything cancels and you're left with 0 equals 0. So really what I'm asking is, what do I want to go right here so that when I have this all set up for everything else to cancel, that these are going to cancel as well? And that would be -9. So my answer here would be n equals -9. Okay, because that would cancel with the +9. Now, no solution happens when these numbers cancel, but these ones over here don't. So it really doesn't, your process for doing 10 and 11 don't change at all. The only difference between these two is what happens with these numbers on the end, and you don't even really have to worry about that. So in this one again, I'm looking for a number to put here, so I can't mess with these too much, but I can mess with the x's. I want to get my x's set to cancel out, and I'm really loving the 3's today. I'm going to multiply this top equation by 3 so that this would become a 3x to mix with that -3x. So when I multiply, I get 3x plus 6y equals 33. And when I add together, these cancel. These over here do not cancel. Let's see, that's going to be 25, I believe. But what I really want is to get to 0 equals 25. That's how I get no solution. Okay, no solution is when I get two unequal numbers, okay, with no variables left. So I still want my y's to cancel just like I wanted them to cancel back here. So what I'm asking myself is, what do I need to go right here to make it so that my y's are going to cancel once I have everything else set up the way I want? And that value would be -6, so that it cancels with the +6y. Okay, let's practice some graphing. Graph the system y equals -2x plus 1 and x minus 2y equals 8. So each one of these are going to give me a line. All right, these are linear equations, so it's going to give me a line. This first one is in slope-intercept form, so I'm going to start at the 1. Okay, so that's my b value. I'm going to start at the 1 on the y-axis. And then this is my slope. Let's see. So my slope is -2/1. I can always make it a fraction by putting it over 1. So that tells me to go down 2 and to the right 1. Down 2 and right 1. Down 2 and right 1. Down 2 and right 1. And with these ones, sometimes it is easier if you have a straight edge of some kind. Let's see. Just getting it lined up here. I think that's going to be pretty close. I'm a little bit off, but that's okay. Okay, now to graph something like this, x minus 2y equals 8. Probably what most of you would want to do is put this in slope-intercept form. So I'm going to do that off to the side here. X minus 2y equals 8. If I want it in slope-intercept form, I want the y by itself, so I would subtract x and subtract x. So now I have negative 2y. This side I'm going to put the x in front because that's how I like my slope-intercept form, is with the x term and then the numerical term. So negative x plus 8. And then I'm going to divide everything by negative 2. Everything by negative 2. So that's now going to say, let's see, y equals, this is negative 1 over negative 2. I would really just get rid of the negatives because you have two negatives that make a positive, but otherwise I would leave that as a 1/2. 1/2 x, and then 8 over negative 2 is negative 4. Now I can graph that. So negative 4 would be 1, 2, 3, 4 down on the y. And then my slope is 1 over 2, that's rise over run, so up 1 and over 2, up 1, whoops, and over 2, up 1 and over 2. Draw my line. And there's my graph of my system. Okay. And then it says use the graph to identify the solution. Now, I have a lot of people, when we did this test on this chapter, there was a question similar to this, and they did all this work, and then they said, oh, well, now I have to solve it, and then they went up here and did like substitution or elimination. You can do that, and I think that's a great way to sort of check your work, but really the point of doing a graph is to use the graph to find the solution. The solution is going to be the point where they intersect. Okay, so that would be at 2, negative 3. So they intersect at 2, negative 3. That's our solution. And that should be the same coordinate you would find if you did do substitution or elimination. You just don't really need to. Okay, let me look and see what's coming next and decide. Oh yeah, I'm going to go ahead and throw these two in with this video because this is more graphing stuff. Okay, now number 13. I want to do this one. I want to graph this first line a little differently than I did a second ago. You absolutely could put this in slope-intercept form if you really wanted to. However, I'm going to graph this using the intercepts, and so I want you to watch what I'm doing. When I'm looking for the x-intercept, at the x-intercept, I know that y is a 0. So I'm going to cover up the y, and I have negative 3x equals 12. So when I divide, I get that the x-intercept is at negative 4. Okay, so that tells me to go to negative 4 on the x-axis. And then when I want the y-intercept, at the y-intercept I know that x is equal to 0, so I'm going to cover that up. Now I have 4y equals 12, so the y-intercept is at positive 3. So I'm going to go to 3 on the y-axis. So I just wanted to review that graphing method with you. You certainly could put that in slope-intercept form, but I'm just hoping not to have to do that. So let's see if I line this up. Should be like this. Okay. And then the equation x equals 4, and when you get to the chapter 3 review stuff, we're going to spend a lot of time talking about these. This kind of equation, remember, dust this off, is a vertical line. Okay, at x equals, anytime it's x equals a number, that's a vertical line. So I'm going to go to where x is equal to 4, that'd be right here, and just draw a vertical line straight up and down. And let's see, it looks like my straight line is a little bit off. I'm guessing it's really supposed to be this point right here. But I can check, because to get from here to here, I went up 3 and over 4. So to get to my next point, I would go up 3 and over 4. Yep, and it looks like this is where that point's supposed to be. So my line was just a little bit off. There's my intersection point. So my solution would be 4 comma, what is that, 6? So 4 comma 6 is my solution. Okay. Let's see here. Okay, so for my next one, number 14, I'm graphing y equals 1/2 x minus 3. Again, that's a nice, easy slope-intercept form one. So I'm going to go to -3. These numbers mess me up a little bit. And my slope is 1/2, so I'd go up 1 and over 2, up 1 and over 2, up 1 and over 2. I'll go ahead and do this one with slope-intercept form because, again, I know that's a method a lot of us like. I just think the intercepts way can be a lot faster for many of us. But if I wanted to put this in slope-intercept form, 2x minus 4y equals -12. I would start by moving my x over, so minus 2x minus 2x. So I have -4y equals -2x minus 12. Remember, I'm putting the x in front because it's mx plus b. And then I would divide everything through by my -4. And when I rewrite it, it would look like this. Y equals -2 over -4. 2 over 4 reduces to 1/2, and then my two negatives would make a positive, so this would be 1/2 x. -12 over -4 is +3. So 1/2 x plus 3. Okay, gosh, it looks awfully familiar. Not exactly the same, but let's look at how that would be different. So my y-intercept is at +3. And my slope is 1 over 2, up 1 over 2. Okay. When I go to draw this line in, it looks like this. So remember, what I'm looking for in terms of a solution is the intersection point. If you look back up at number 13, I was looking for the point where they cross. These two lines don't cross at all. This is a no solution system. We call that an inconsistent system because there's no place where these two lines are, ever going to cross. This is one where if I set it up and solved it, I would get like 0 equals 5 or 6 equals 4. I would get two numbers with no variables that don't equal each other. So that's what a no solution system looks like graphically.